So, thank you. Glad to see you all here. I want to first start with some stuff. So I wanted to thank Vanya for basically inviting me in the most passive, give me anything and I will approve it sort of way, which I think that's why I got in. I'd also like to thank Christian, Simon, Martin. I think I missed some of you, and you're multiplying, and I'm terrible with names, and so I don't know who is who. But for finding space and food for us to come together every month. So thank you. And so finally, this talk isn't interactive, because I'm a hack, but you should feel free to ask questions as we go along. Heckle liberally. I talk way too fast, so if you want to complain about that loud and verbally, feel free to do so. No, like about that. Yeah. And yes, I think that's good for now. So, who am I? Obligatory self-introduction. My name is Mark. I'm a former musician, now I'm a programmer. And I build audio software as a result, mostly for desktop, but some for terminal and a bit of web. And I think, as you might have guessed, I'm passionate about low latency, keyboard-driven programs. Like, who could imagine? So, speaking of low latency, keyboard-driven programs, why terminals? You should tell me, why are you interested in terminals? So you could be anywhere, but unless you're really excited for the raffle, you're here because you want to be here. So do you have any interest? Yes.
I hate the mouse.
Okay. Yeah.
Is there anything else?
You know, I've heard of this radical operating system from Bell Labs called Plan 9, and they have this thing that you were just talking about, a mouse. Yeah, and you can do weird stuff with it. It's totally out there. So I'm just going to pick a few things, but I've already picked them, in order of, shall we say, least credible to most credible. So nostalgia. Some people grew up, and in the poor minds of the 1980s, the only thing that people could afford in their homes was these text-based computers. And so terminals bring you back to a more simple time. But despite what a decade of liberal drinking and very light sleeping have done to my face, I'm actually a child of the 90s. And so my first computer ran Windows 95. And so this isn't really my kind of nostalgia.
That explains a lot.
Yeah. So next, there's portability or simplicity. And the appeal, one of the appeals of making terminal programs is the interface is very simple. You're just getting in a byte stream and you're feeding out a byte stream. And when you compare this to something like React, a whole web front-end setup, it's pretty simple. Not a lot to keep track of, and not a lot of concepts that you need to really understand to be able to get some work done. There's my personal hobby horse, which is text-based UI built around keyboard controls. It arguably offers the highest bandwidth exchange between human and computer possible with today's technology. And I'm willing to litigate this afterwards in the bar and not now because it would take too long. But get into it with me. So what are we going over today? We have what is a terminal. If you don't know what a terminal is, why are you here? But good luck. But we'll cover it and we'll do some basic terminology. The real meat of this is what are some cool cross-terminal features that you can use in your programs. So there's really cool stuff you can do. You can show images in the terminal. There's so many different terminals out there and they all have their own features, and we're not going to get into it. Because, okay, there's a terminal. It lets you show images. There's like 2. And if you use them, that's great. But if you're writing software and you want a lot of people to use it, then maybe it's a little difficult to convince them to use your favorite terminal program. Talk about making UIs with Unicode characters. There's a lot of stuff that you can do, and so we'll go over some of that. And then if we have time, and if I'm talking this fast, we are going to have time, we can go over how you do faster animated things in the terminal.
Like Star Wars.
Star Wars?
You could watch New Hope in a television.
You could. That's not really animations. That's more like using VLC as God intended. But let's go over terminology. So we have, starting with a terminal emulator. So this is another one of the things that we can go over in the bar. I just call it terminals, and it's because the idea of a terminal emulator is it's a program that emulates a terminal. So if you didn't have a home computer, but you had a computer in your office in the 70s and the 80s, chances were your company didn't want to buy a computer for everybody. So they bought one computer for a bunch of people, and then they bought individual people what was a terminal. And that's like a combination of a keyboard and a screen. Later ones would also have a mouse. So the reason why people call them terminal emulators is because they say you're emulating that sort of setup. What I would say is that people are usually trying to follow certain engineering specifications when they make terminal programs, and they don't really care how the hardware works so much. So yes, it's similar, but it's not really an emulator in that sense. So then you have the shell. The shell is a program that takes in input and then runs other programs in specific ways, and then takes their output and brings it back to your terminal emulator so it can display it to you. And then standard streams. So this is std.io, std.out, std.air. And in C, you access these through file descriptors, and you can do file descriptor things. I haven't done a lot of C file descriptor stuff, so you're going to have to take my word for it and you're fill in the blanks. But in Rust, std.in is accessed via the read trait. std.out and std.air are accessed via the write trait. And you can also access them via files if you hate yourself and you actually want to be programming in C, which does raise some questions. So here's a basic block diagram. We get into the first of many examples of me not possessing any sort of graphics design skill. So on that note, starting at the bottom left, you have your keyboard. So you know, also a mouse. So let's say input devices, but generally it's just a keyboard and a mouse when you're doing terminal stuff. You know, this goes into your kernel, which does something with it to send it to your operating system. Your operating system provides an API for user input devices, and your terminal emulator is like an application, and that's going to take in, you know, input from your mouse, your keyboard, and it's going to give that to your shell via std.in. Your shell is then going to make its own set of std.in, std.air, and std.out for your program, probably. It can technically forward the ones from the terminal emulator over to the shell, but it probably won't do that. Your program gets input, and it prints stuff out. Maybe, I mean, it can. And you then send it back if it's normal output via std.out. If it's errors, you send it via std.air. Theoretically, your shell can do the same thing to the terminal emulator. Practically, your shell is probably going to take your programs, std.out, or std.air, and if you do your redirects correctly, it will convert it into std.out, and your terminal emulator is probably not going to display std.air by itself. So then your terminal emulator is going to go to the operating system and say, hey, I have stuff for you to draw. However, you're doing that, you know, GPU, CPU rendering. The possibilities are limited. And that then takes it to the kernel, which figures out how to you know, actually output it to your hardware, which is probably a computer monitor of some sort. I haven't checked recent trends, but I'm pretty sure that's where we are. And the final kind of piece of basic infrastructure are what are called escape codes. So these are in-band ASCII, which is so my speaker notes do not match the slides. Great. So, but this is a good place to start. So it's a set of commands covered by ISO 6429, which is also known as ANSI X304. There's a bit of history on like who owns the specification, but ANSI at some point owned it, and then they're like, we don't want, no. Yeah, we don't want to own it. The ISO should own it, and so they transferred it. But it's like, it's the same specification. And this, basically the idea is that you're sending bytes, which are ASCII characters most of the time. You can send Unicode, and you know, things recognize Unicode, but at a basic form, the expectation is that at least you recognize ASCII. And so escape codes are an ASCII string sent via std.out, and they're meant to be consumed by the terminal. And wow, that is not quite it. Well, all right. So this is a good place. This isn't the whole presentation. That slide should be there, but there should have been an extra bullet point. So not catastrophe yet. If you have any questions, though, now is kind of a good place to stop. Yes?
What's your favorite escape code?
alternate screen, because I do a lot of interactive programs, and so I need to be like, hey, give me my own screen so I can do stuff. Some other people?
Can you put favorites on all the boxes you showed? Kernel, operating system, terminal, shell.
God, I wouldn't say that I have a wide berth of experience, but mechanical keyboards. We can again go into this in the bar. I like my BSDs, but Linux just kind of works without a fuss. Terminal emulator, Alacrity, shell, equal distaste, but I'm using KSH now, and it's got some problems, but it works. And my programs are my favorite your programs. So actually, if anybody else has any questions, we can still take them. But yeah.
What does it indicate that you left out a terminal multiplexer in this list of boxes?
That's a your program sort of thing, But no, I am frequently using tmux, and it's too slow, and we can get into that later. But I do use it, but it comes after the shell, and so it really still fits into this whole paradigm. And it's actually kind of an interesting thing to cover. It fakes kind of having a bunch of things running, and actually it does do these things. But it basically gives a stood in, stood out, stood air triple to a bunch of child processes, and then those send back stuff through stood out, and then it combines all of them together and sends it through an individual stood out back up the chain, so to a shell. Which then to your terminal emulator. So, yeah, so there are a few crates for doing terminal stuff. That's a verb, I guess, in Rust. Let's go over them now. So, by popularity, I actually don't think this is the most popular one. In an arbitrary order, but with the one that I actually use last, because I have not used the rest of these, let's start with CrossTerm. So this is a cross operating system crate for sending escape codes to a parent terminal. So why cross operating system? Well, so there's this whole specification, the standard I've told you about, and Microsoft is too special for it. So for a very long time, they didn't offer anything that was actually ANSI compliant. So command prompt isn't, PowerShell isn't, Visual Studio's command prompt, which isn't command prompt, also isn't. But they have started shipping things with Windows 10 that are. And on Windows, if you want to have ANSI compatible stuff, you can use MingW and Cygwin for those sorts of things. Or you can, if you're using Windows 10 or Windows 11, Microsoft offers a terminal that does implement the ASCII specification, and so your fun escape code stuff will work there too. But assuming that's not you, you can use CrossTerm, and it will work with command prompt and PowerShell. So I've been told. Yeah?
How about Windows subsystem for Linux?
That ought to be implementing stuff normally. I don't know about the actual, window that it runs in, that command thing, but it's been a long time since I used WSL and never version 2. But there's nothing inside of the subsystem that would prevent it from working. So it basically gives you a bunch of commands for sending certain escape codes. So escape codes are these strings, and that's really cumbersome to work with them. I have an example we'll see. And so one common theme with a lot of these things is they abstract it away via functions or types or some other way of not actually having to deal with these strings directly. And a lot of these libraries also abstract away exactly writing to std.io. So using CrossTerm, you have to give it a std out if you want to write to it, but it sort of handles when exactly it writes and how the mechanics work under the hood. And so it's a little more convenient than handling it yourself, but it does make it complicated to do performance tuning. So we have ncurses and pancurses, and if you know what ncurses is, you know why this is important, and if you don't know what ncurses is, nice, I envy you. So they're thin Rust wrappers around popular ncurses library, and in fact, pancurses is a wrapper around ncurses and something else which works on Windows and does ncurses things on Windows. And these crates link to ncurses dynamically, and on the one hand, that means that ncurses has to be installed on your target platform. On the other hand, I have run a very minimal Gentoo setup before, trying to get rid of as much shit as I could, and you can't get rid of incurses. So probably not that much of a liability, if we're being honest. Ratatouille is the standout here. Yeah. And so these other crates are more for actually managing escape codes. Ratatouille is for actually doing more framework-like stuff with TUI programs. So it's based off the now abandoned TUI crate, and it comes with a lot of widgets and utilities, so batteries included sort of thing. Works with several backends. Take their word for it. And it's immediate mode, and I assumed that this would require completely redrawing every frame, and that's problematic for reasons we'll get into later. But you say that you can actually tell it to not do that.
Somewhat.
Okay. So it's somewhat requiring you to completely redraw every frame. And then finally, my hobby horse, not mine, but the thing that I use is Termian. It's a light abstraction over these specifications. Mostly provides types that do that implement display, and when you call display on it, so when you put it into a format string, it gives you the actual string of the escape sequence out. Theoretically, it's compatible with any ANSI-compatible terminal, but I do recall having problems compiling it on Windows. This was a couple years ago. I'm blessed and I don't have to use Windows very often. So, but it was like one of the dependencies had like a configuration flag, and it's like, I'm in Windows, I'm not doing this, and not like a real hard reason why it wouldn't work. It leaves you to manage std.io, and that makes normal use complicated. But when you need to go optimize it, it's really easy because you have control over when it does syscalls. So, questions if you got them?
Yeah, I'm using something called Cursive. That's on a higher level, but it's on a higher level than the Cursives.
Yeah.
It still is.
Yeah. From the very small amount of incurses I've seen, it's like higher level than working with the strings, and it does have some utilities for doing combinations of stuff, but it is still pretty low level compared to something like Cursive or Ratatouille. I was just like, oh, what's popular so I can give a representation. I saw Cursive, but I was like, well, pick 4 and it's not on the list, so sorry.
Does Termion ignore term info and things like that, and just relies on the escape codes being those defined by the address pack?
Yeah, so my understanding is that it's meant to kind of stand alone, and so it just assumes that it's whatever it's working with is compliant.
The database of escape codes for specific terminals.
Yeah.
The reason why you launch something in Tmux, or not Tmux, but RxVC, for instance, and stuff like, I don't know what's going on.
Yeah.
And then you tell it, it's Xterm. It's like, oh, okay. I know Xterm, it's fine.
Yeah. No, it's a lot more simple than that. So this is going to be the only code examples we have in this talk, so we can all get through it together, but you're going to see why there's not a lot of code examples, because the code here is pretty easy. So let's start with colors. The easiest way, okay, so you've two kinds of color. You have text color, which is called foreground color, and then you have the background color. And I thought I had a different thing here, but apparently I don't. So one thing to keep in mind with all of these is the way that they work is they don't change all of the color on the screen. They only change what you write after you set the color. So if you have a screen full of white text and you change the color, none of that text color is going to change. When you start entering new text, then that text will be the new color. Same with the background stuff. So the easiest way is with Pallet, and again, there's a whole specification here, but we're just kind of going to bulldoze over that. Lets you choose one of 16 or 256, depending on your terminal and what exact escape codes you're using, colors. And in stuff like CrossTerm and Termion, this lets you say, like, I want red, I want light red. So not very specific colors, but if you're just like, I need this, it's really easy to bang it out. So code examples incoming. Let's do it with a raw string. So pretty easy. We read a file to a string, and this is a non-existent file, so we're expecting it to be an error. And we have this variable red, so this is the escape sequence. I'm sure you all want to be typing this all of the time. It's super easy to read, totally comprehensible. You'd never make a typo, would you? Okay, not the enthusiasm I was hoping to hear. So normally you would call write, but I felt lazy in this example, and I instead call printline, and because that works too. And so I format the red variable, which implements display. Or sorry, it's string. That's a later example. So this is string, obviously, and implements display. It's a STRI reference. Same thing. And then we, say, okay, we got an error, and then we, debug it out. And that looks like this. So okay, plausible. But yeah.
Yeah. Was that like a Unicode escape sequence for the red color?
Yeah. So this is the ANSI escape sequence. It's not Unicode.
Okay.
Well, I mean, technically, but.
How is it structured? What's the?
Yeah. So you have like a kind of. The whole point is like to say like you don't want to be doing this. Let's do it a different way. But if you really want to get into it, you have your header. So that's this hex literal, which is x1b. So that decimal 27. This doesn't really display as a character when you want to type a character in. So you use this backslash to say this is a literal, and then your left square bracket. So that's saying I'm starting an escape sequence. And then the 38 says I'm drawing some palette color. 5, I think, is red. I could be wrong on that. And then I think the 1M says I'm done drawing a palette color. But I curse the day that I ever have to program like this, so I'm not super familiar. This is arguably easier to read. I think it is. So same example as before. We're reading stuff from a non-existent file. Now we're using these colors, red and white. We say, let's set the foreground, so the text color, to be red. Let's set the background to be white. So we set the foreground color. We set the background color. We print out got error. And then we print out the error as before. And then we print finished. And so, as you can imagine, this does the right thing, but I maybe should have specified this. If we want finished to be the original text, obviously, or the original foreground color and background color, this won't do that because the color settings are stateful. And so you've changed them, and they're just going to continue printing out that way until you change them to something else. So we can come in and we can say, yeah, that's the example. Okay. We're going to improvise. So if you wanted to, yeah.
But what about my night mode?
Yeah, well, you'd have to change the colors differently then. I don't think there's an actual way that you can like say, I'm a dark mode terminal though. Using just the ANSI specification.
Technically, you're using palettes.
Yeah.
The underlying color is not
right
specified.
But like, yeah, I mean, okay, so if you use palettes, but then the second you go into like true color and yeah, then you start to have problems. And we'll kind of get into that in a bit, but this is the wrong picture, so bad mark. But the gist is, okay, maybe you want to set it back. So this is the same example as before. You might say naively, okay, so I set the foreground text to white and I set the background text to black, and okay, we get something resembling original terminal output. And if you do that, and your colors are in fact not white and black, you end up with something that looks like this. So let's say that I'm cursed and my terminal is green text and a grayish background. We start to get something like this, and if you look at the end here, you can see the background abruptly changing color a few times. So maybe not quite right. So instead, are you fucking kidding me? I have a completely different slide in my speaker notes and on the screen, so that's a great fun. I'm going to try a sneaky maneuver here and see if this helps me out. This does not help me out at all. Really not at all. Okay.
It's because your slides aren't terminal based.
I tried, and I had 3 days to write it. So. But this is the actual slide I wanted to show. So as before, but after the error, we use this reset object, and that implements display, and that sends its own escape code, and after the error gets printed out, it then resets actually a bunch more stuff than just the color, styles as well, which we'll get into in a bit. And that looks like this. So, okay, plausibly correct. I changed my terminal colors back to not be cursed in between these two examples, so you're gonna have to take my word that it works, but green text on a gray background, I mean, come on. And yeah, maybe we want to do true color stuff, but
You
yeah.
say, come on, but aren't your editor style that? Green text on a gray background.
No, this is the presentation software. I've copied this into an HTML document, and it thinks that this is Monokai in Rust. Yeah, skeptical as well. So I'm just going to try reloading this and pray that nothing goes wrong. Okay. I can't get it out of full. Oh, there we go. Perfect. Yeah. No, that does not look like it's doing it. Okay, so you can also do arbitrary colors in Termian. So there's two kinds. There's the, wow, this thing has no chill. Okay, cool, really cool. Working as intended.
Are your notes correct?
They're actually, yeah, my notes are correct.
Can you show the notes instead?
I might be able to, but it's, you know, all like super tiny and shit. So let's see if I can zoom in. Well, so I thought Safari was designed by the people who really have like the typographic graphics design mindset, but so if you can you read this? Because otherwise this is kind of pointless. Okay, great. So really similar as to before, but I just picked these two arbitrary orangish-brown colors, which you can see coming up there. You got two ways of doing it. So the traditional, I want to choose any color, you use what's called an ANSI value, and this takes in 3 U8s, but you're only allowed to go from 0 to 5. So you get about 256 colors. And maybe that's limiting. I mean, you know, we all have our triple CRT monitor setup. We've all watched Lane, and you know, we want to be the guy with the 6 CRT monitors in front of him. But sometimes maybe you don't have a CRT monitor. You have something with like more modern color range, and you want, I don't know, like 24 million colors or something like that, or 24-bit colors, sorry. And so in that case, you can use the RGB thing, and that lets you do the standard RGB U8 triple to get arbitrary colors out. And so the example code might be screwed up, but you know, at least the beautiful brown color has been preserved. And now I've made the wrong thing full screen, so hold on. Any questions or? Okay. Cool. So next we have styles. We're out of the code section, so no more code from me for the rest of the presentation. You got a few that are widely supported according to the docs. That's bold, italic, underline, and inverted. And you have a few that are not widely supported according to the docs, and that's strike through, which is called cross out, blinking, faded, and framed. This is what it looks like on my computer, and so HTML is like not my strong suit, so I can't figure out how to make the image not be super tiny like this. But if you go download the file, what? Yeah, well, that's because Alacrity does not implement blinking. macOS Terminal does, but otherwise it looks the same on both of them. So you're not missing much though. And then you can also undo styles, so you can say, so these are all types with the exception of strike through, which is crossed out in Termian. And you can put no in front of them. So you can say no bold, no italic, and switch that off. And why you might want to do that as opposed to resetting is depends on what you're doing with your styling. And then also there's performance reasons, which it approaches.
Can you combine the styles?
Yes, I think. I'm not entirely sure.
Italicized, strike through.
Theoretically, there's nothing stopping you from, you know, just like chaining these together. I think what actually happens is sort of up to your terminal. I am a Spartan person, and so I don't actually use any of these. plain text works for me.
Use most of them in two, but yeah, it's up to your terminal.
Yeah, and the bottom line, for example, not really supported by a lot of stuff anyways. And I think a lot of the cooler, newer things are kind of like, no, it's too slow to figure out how to do all that, so we just don't. So, doing graphics in Unicode. It's a hard job, but someone's got to do it. It could be you. Legacy characters. So going back to that nostalgia thing, these are a group of characters that reproduce graphical characters from popular home computers from the 1980s. So as you probably know, ASCII is 127 characters, but it fits in 8 bytes. And so you got people asking a question in the 70s and the 80s, which is, hey, wait a minute, I got like 127, 128 empty cells here. Why don't I put stuff in them? And so everybody put their own cool stuff, and none of them are compatible with each other. There is a page in Unicode that attempts to kind of like take the greatest hits, if you will, and put them into one set of characters. And so maybe your favorites are in there. There's also a special one for some IBM computer. Again, I really don't care. What I do really care about, kind of, are box drawing characters, respectable. You can do cool things in them, like draw Linux's menu config, or FreeBSD's boot screen, or grids, frames, and really like the menu config thing. You can do like all these shadow and relief things, and do kind of detailed stuff that you wouldn't necessarily associate with text interfaces. So also good for lines and grids. And I have some examples in the slides, in the code examples source Unicode grid thing. Yeah, folders, too many of them. So a grid, for example, you can do this sort of thing. And if you notice, if you're smart about it, you can kind of combine these. So you have a solid line here, but then you also have a join here. And if you were smart and you noticed this when you did the screenshot yesterday, you didn't leave the kind of thing leaving off the right side, but there is something that actually terminates here, and also on top and on the bottom. But again, UI, not my strong point. Block characters, these are my bread and butter. So these are a group of characters that are mostly differently sized blocks. There's also some lines. And they go from left to right and then from bottom to top. So the blocks fill in from the left to the right in 1/8 increments, and then from the bottom to the top in the same way. I think there's an alternating set that go from top to bottom, and that one's a little finicky because a lot of terminals don't really align it correctly. And so you're kind of like, yeah, I have a block here and then like part of a block hanging down, and your terminal's like, I'm going to put a little space in between the two, because you wouldn't want these things to be combined. I mean, that would be terrible. So never a dull moment. Great for drawing shapes, progress bars, bar graphs. Also examples, also unfortunately done folder paths. This is an example of a progress bar. So this is Alacrity, and there aren't actually these black lines in the middle here, just in the recording software. But those sorts of artifacts are what get really common when you start to get a little more exotic in what kinds of block characters you're combining together. Private use areas. Okay, so you have ideas and you need your own special graphics. So Unicode Consortium has you covered, and they have certain pages which are intentionally left blank, and you can fill them in with whatever you want. So if you have some font that really does what your program needs, you can ship it, and then you can put arbitrary cells or glyphs, or whatever you want to call them, glyph in the visual sense, but I mean it's something, into these locations, which are the last 2 pages in the Unicode code page block, whatever thing. I'm not really a huge Unicode person either. But for example, this is how Nerd Font patches symbols into other fonts. It basically says, okay, give me your font, and I'm just going to assume there's nothing in any of the PUA stuff. So I'm going to stick all the symbols here, and then things that use nerd fonts just know where those symbols live. There are events. Should I? Okay. Lightning round, maybe, could be. There's several event types and some things that you would kind of hope would be supported in a comprehensive framework that aren't. So keyboard keys, if you've done anything with Winit or a lot of the UI frameworks in Rust, you're probably used to having a large enum for handling key presses, and Termion as well. Key presses are detected, releases are not. It's stood out. You get what you get, and what you don't get are key releases. There's ways around that depending on your operating system, but again, not really cross-platform. You can use the mouse. Plan 9 believers, power users, rejoice. So it's relatively common in terminals. So for example, you can do text highlighting and all that stuff. And you have the usual mouse stuff. I think this is the part where my brain is broken. So you have a left, right, and middle mouse buttons. You can detect, press, and release the cell in which they were pressed or released. And then if you drag, you can detect the cell that's that the cursor is over if you're in the middle of a drag. And then you can also detect the scroll wheel. And then so one thing you might hope would be handled but aren't are signals. And so these are, it's complicated, but the very abridged and borderline incorrect view is that these are notifications for when to quit, pause, resize, and do other stuff. Like it also tells you when you had a seg fault. So that's good to know. And yeah, really, there's a lot of stuff going on here, and it is kind of in its own little world. But I use SignalHook to handle all this for me. You can use libc, again, if you secretly wished you were programming in C, which raises questions, like just do it. And yeah, so feature lightning round. But if anybody has any questions, I probably need to take a bunch of water, yeah.
What's merge funds? Way out of the loop.
So have you seen like people have these fancy terminal decorations going on? And they have like symbols. So sometimes they'll be like, oh, you're in your Git repository, and I have like a little kind of tree symbol. And it's just a whole bunch of like commonly used symbols that are sort of provided in one location. And then a mechanism for downloading them and using them with different fonts is the uncharitably high up view, also because I don't use them. So yeah, so raw mode, kind of part of your bread and butter if you're making interactive stuff. So not stuff like LS or other core util popular programs, but stuff where you're actually interacting with something and the view is persistent and not just text lines being output. So in raw mode, stood in is no longer automatically drawn to your terminal emulator screen. And it's also not line buffered anymore. So you can detect individual key presses. So normally, if a user types something, it doesn't make it to your program until they hit enter. But when you turn on raw mode, that gets disabled. So you're able to get key press by key press. So the new line character no longer does what you would expect it to do. It just moves the cursor down. You need to use the whole carriage return to move down and back to the beginning of the line. Why you would want to do that as opposed to some of the upcoming features, again, we'll get into. But there's also the alternate screen, so briefly touched on this, but this tells the terminal, like, hey, take whatever you're doing now and put it aside. I want to draw in kind of my own context. And realistically, your terminal emulator only has to provide 2 of these screens, so if you need more than that, tough shit. But yeah, that lets you do nice stuff like if you think of stuff like Vim or Emacs, I assume, pagers, things like that, where they do their own full screen thing and then you quit them and then you're back in your terminal session. This is how they do it. They have an alternate screen and they draw to that, and you just use that and only that for the lifetime of your program. So Termion specifically provides scoped wrappers. So remember, the way that you kind of do all these things is with ASCII strings. And so you sort of have your usual, new free problems where you need to remember to turn the thing off after you've turned it on. And so these scoped wrappers will go into an alternate screen for you. They turn on mouse support for you. You can turn off the cursor, for example. They save the state of whatever it is, and then on drop, they restore the state. So they provide this RAI style interface. and they're available for a few things. They can be composed. So when I open up one of my programs, in Rust, kind of the first thing I do is I change the screen mode, turn off the cursor, and enter raw mode. So really common, handy thing to do. So terminal state is restored whenever it's dropped. I don't know why I said the end of runtime, but probably because that's when I drop it, which is great if your wrapper is dropped. So if you aren't handling signals, like for example using signal hook, then the operating system just takes out your program, and it's like, well, listen, I can free the memory myself. I'll just set it all, to whatever it needs to be set to, and then, like remove it from whatever page tables and whatever, which is great, but it means that drop isn't called, and so your terminal state isn't restored. So next is cursor movement. So whenever you are outputting characters, they happen at wherever the cursor is. And so, and when you output a character, the cursor implicitly moves one unit to the right. And so sometimes that's not convenient. Like if you want to draw a box, you need to be able to go straight down. And so there are commands to move the direction in a certain number of cells in any of the cardinal directions. And then there's also a go-to command, which allows you to move to any arbitrary cell in the terminal. And very cool, it's one-based indexing. So everything that you've rigorously taught yourself about how to index through things, you can throw right out the fucking window and learn it all over again for this piece of shit. You can clear the screen in many exciting ways. So you can clear the current cell. You can, that's actually just, a space. You can clear the current line, the whole line, before or after the cursor. You can clear the whole screen. And that's it for the lightning round on the features. And now, everybody's favorite, performance tips. So your usual tips and tricks for writing fast code apply. There's nothing like magical that turns fast stuff slow inside the terminal. There's no control over when the terminal redraws. So if you're doing very fast animations, this can be a problem, because if you are invalidating a lot of the screen space and then changing it, the terminal can decide to redraw you in the middle of that invalidation. And so if you're tempted to say, like, I'm going to do the immediate mode GUI thing, clear the whole screen and then redraw it, Murphy's Law says that you're going to clear the whole screen, draw like 3 lines, and then the terminal emulator is like, now is the time for me to redraw this thing. So in general, if you're trying to avoid visual artifacts, the less data you send, the better, and the more similar successive frames are, the better. So like the more, shall we say, valid, if that makes sense, your input state, the state of your screen is at a given time, the better, because it means that even if something is displayed that shouldn't be displayed, it looks kind of right, hopefully. So also reading and writing to std.io are system calls, and so you want to do that as little as possible. Reading from std.in flat out blocks, and so you probably want to use async or threads, pick your poison, to actually get input and then send that in a non-blocking way to your main event loop. And so that's pretty much it for the talk, but I have a demo. But if any of you are photosensitive, we probably don't want to be doing that. So does that describe anybody, like bright, flashing, white on black background? Is that okay?
Anybody have any epileptic episodes,
Yeah.
seizures, anything like that in your history? No, it's just the time to raise your hand.
I'd rather know now, but one of these is the right terminal window, I swear.
Could you make the font a bit smaller?
Yeah, I can actually. But thankfully, you're not going to be looking at the font, so don't worry about it. So this is something I'm working on. It's an oscilloscope. And this is a pretty good example of like what happens if you you clear the whole screen between successive frames. So you get this really excessive, like blinking and screen tearing kind of in the best case. And it just in general doesn't look very good. This is like doing weird stuff to the input, and it's also, I think, 30 frames per second. So this actually looks nicer than it usually does, or more smooth, let's say. But if you sort of do the thing, one sec, with the where you don't clear the whole screen and you just do these small changes to the characters that are on screen, you can get it much smoother. So even though this TV is like not the paragon of, shall we say, visual fidelity, you know, you can kind of see that there's a lot less visual artifacts and the animation is quite a bit smoother. So that does it for me. Anybody has any questions? Feel free.
Being filtered into a sine wave.
It's just a sine sweep. It's you know, sampling is hard, right? So, yeah.
We're talking about the artifacts. Those are glyphs, right? No, it's the wave itself that has this one.
Yeah, so it goes from like 20 hertz to 20 kilohertz. So when it looks like that, you know, straight line, it's basically just 20K. And the width of the scope changes over time. So, you know, like at the 20 hertz thing, it's like, I don't know, a few dozen or maybe 100 samples. But at 20 kilohertz, it's 2 samples, this one and that one. And so it just lerps it. So, yeah. Yeah.
Audio software, is that what you do for a living, you said?
Yeah.
And
Usually not this kind of thing, you know, more boring stuff. But
I was going to ask if you use any terminal stuff.
yeah. So as a joke, the thing I did before this was a frequency analyzer. And so, you know, I'm like, oh, it can be done, so I'm going to do it, ha, 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 ha. And then at some point I was building something, I'm like, oh, I need a frequency analyzer. Oh, the only thing I have installed is this one. And I just start using it, and like 20 minutes later, I'm like, wait a fucking minute. You know, it just works unironically as a tool. So I'm sort of take this attitude of like, I'm not tied to designing stuff in the terminal. You know, I'm not like, oh, this is the only way you can build programs. But I'm sort of like, you know, when it gets more inconvenient to do this than like a GUI application, I'll stop and I'll switch for, you know, whatever the application in question is over to the GUI stuff. And surprisingly haven't quite hit that point yet. Do you have some? Oh, no, yeah.
The input for that wave generator, is it just...
It's just a sine wave,
Okay.
swept from,
So
yeah.
you're not doing any input, like, from...
No. It's such a hassle to do microphone input in Rust because of permissions on macOS. Right, you know, it's the usual like, you can't access the microphone. I'm not going to tell you can't access the microphone. There just is no microphone.
Okay.
So, yeah.
What are Vim and Emacs having differently that is have not seen this tearing that you described? Not like this.
They're just not updating every frame, right? So that is, I have like a 1/60th of a second sleep, and that's how I'm getting that refresh rate. I mean, it's more complicated, right? It's like, okay, when does the frame start? Okay, you know, it's the elapsed time to do all the rendering, you know. But, you know, Vim and Emacs, they're only updating when an event happens or when you move the cursor, so when an event happens. And when you do that kind of stuff, you can clear the whole screen, and it's generally okay, you know, especially because you have like one frame where there's an artifact. So even if you do have that tearing, it looks okay almost all of the time. With something like this, I'm not super into like graphics, but my understanding is that like it kind of looks wrong about all of the time or frequently, and so you start to be able to notice like, hey, you know, this thing isn't really a full line most of the time. Your eye doesn't really fill in the blanks for you, I guess. Yeah?
You mentioned the blocks as something, but not Braille. Stuff like the
So
program does nice things with covering individual dots in Braille.
the which program? Oh, this is Cargo, I think.
The program is called Bottom.
Oh, yeah, I've never heard of it. So actually, I do have this, which is not going to work now that I think about it, so I don't do it. But my weather program runs in the command line, and it does use Braille characters, which is what got me started on this whole thing. But the problem with Braille characters is that it's a huge pain in the ass to like actually use them, I think, effectively, and not having some convoluted like table lookup thing that's also performant. And also, so if you notice with the oh God, too many windows. So if you notice with this, still in development, so that's why you have all this jagged stuff up here. You know, I have the whole area filled in, and it's a lot harder to do that with the Braille stuff. And the problem is, if you just have the Braille dots, it's like so small that it becomes really hard to see in a lot of conditions. And so it's like, yes, it exists, and yes, you can do stuff with it, but at least for the stuff I do, It's just not very convenient. All right, well, that's cool. Too much crap open on my computer. Yeah?
I can't remember if you talked about it, but Unicode,
Yep.
like emojis and stuff, is that the response?
No, that's its like own thing. Ever expanding, more emojis, more expressions, year after year. Sorry, where was I?
Independently defined Unicode characters. Okay, but some terminals just implement and you can put fonts.
Well, so your font implements that. Good terminals, render your fonts, and they render in full Unicode and everything correctly. But the thing is that like certain things are covered in emojis and certain things aren't. Yeah. And also, I would say the nerd font stuff looks pretty distinctive compared to the emoji stuff, right? So a lot of the popular emoji stuff, it's a lot of like, okay, there's some backing shape when you have a pictograph, right? So it's not just the symbol; it's like the symbol in like a square background or something. And a lot of the nerd font stuff is just the symbol, for example. So it gives you more control over the appearance as well. You and then, yeah.
In the introduction, I thought you were going to say a few words about SixL as well, or did I misunderstand that?
Yeah, the words were, there's Kitty and something else that supports SixL, so I'm not going to get into it. And really, yeah, it's cool. So for people who don't know, SixL is this protocol for allowing you to draw images to some resolution inside of a terminal, and not doing like the semi-graphic thing where it's the really blocky thing, but it's actually fairly good color representation and fairly good resolution and aspect ratio. But again, it's not very widely supported. And if you look at it, I think there's a lot of open issues on a lot of terminals. Like, we should totally do this. And it's like, it would be great. But no, I'm not in any hurry. So
there is a patch set for URXVT, but it hasn't been merged for years and years and years.
Yeah. And I think in Alacrity, they're like, we want to put it in, but who knows the performance stuff. So I'm not saying no, but I am saying like it's a huge pain in the ass and probably not happening. Yeah. Oh, right. Yeah.
Again, back to the Unicode.
Uh-huh.
Can you do like cross-line characters?
Depends on what you mean by cross-line characters. So not really, but you can. I'm not entirely sure if there's some characters that go multiple lines. I don't think so. Some go multiple spaces.
Even some of like Asian characters go above and below the line.
I think that might have something more to do with like the directionality of the text than, but I'm not entirely sure.
And I think there are modifiers for that, like below line. But
do you know?
The styles apply to like non-normal characters. Can you apply a style to a block? Like
like one of these blocks or something. I assume it just does nothing. I mean, because the thing is that like for a lot of this stuff, it's defined by the font, right? So when you say draw it bold, it's like, okay, what does the bold thing do? And okay, it's a block that takes up the whole cell. So when it's bold, it's also a block that takes up the whole cell, kind of thing.
But what if I want bold Braille in Braille?
We'll look into it.
mentioned that tmux was slow. Is it to do kind of rendering?
Yeah.
Because it
just forget it.
goes through.
Yeah, because I assume, there's no technical reason why a terminal emulator couldn't do this sort of thing quickly. And there's actually a lot of technical reasons why a terminal emulator could do it quicker, because it's basically cutting your screen in half so you could just draw less. I guess whatever it's doing, it needs to crunch on the different input or inputs from the output streams, and that takes some time or something. It's similar in Zelig, not quite as much of a problem. And it's again, for most stuff, it's fine. But for me, it's more of the like, I use a terminal multiplexer all of the time. It would be really nice to have something that doesn't choke on the stuff that I work on semi-frequently.
For those that don't know, Zelig is a
Rust terminal multiplexer.
basically a T-box would be written in Rust. With skinning pretty popular.
I think that's a little generous.
Zelig, so it's Zellij, I think. Like Zelig. But it's it's pretty good.
Something like Tmux must emulate in normal mode using raw mode, and does have lots more updates to the screen than a regular terminal. So if you do something like ls/bigr and show all your hard drive, it has to do a lot more screen to do what it's doing. So that's why it cannot be as fast as a raw terminal. It's not as a raw terminal, but as a natural terminal.
I don't know how much I agree with that. I mean, yeah, it literally can't be as fast, but most of what you're doing is like what it actually has to do to display is kind of translate from one coordinate space, the parents, the child's, into whatever pane that it's being drawn into, and it has control over batching and how frequently it updates and how often it pushes out, and from what I've seen, I don't get the feeling that it's like, oh, it's every time it gets a character and it's like drop everything and put it out. And because otherwise you would just have more screen tearing. You wouldn't have like kind of the lower frame rate that I see in CMUX.
Yeah, but what I'm saying is that if you have in your block diagram, if you have a program that's outputting a lot of text to the shell, go back to the terminal, and not use raw mode, that just means that whenever you append a line and you just happen to reach the bottom, then it's the terminal that can use like its native underlying graphics function to like scroll up and do natural things, whereas TMUX has to emulate that using raw mode.
Yeah, but I'm not using scrolling, so I'm not using scrolling, for example.
No, okay, but I'm just comparing.
Yeah, I mean, again, like I think there's differences, or not differences. I think yes, TMUX does have to do stuff specific to TMUX to actually draw stuff, and there is a performance penalty to doing that. But the frequency analyzer thing I'm doing is like can render theoretically at tens of thousands of frames per second. So I find it really difficult to believe that you can't make something that does the layouting in a way that also doesn't degrade that below 60 FPS. So
there's a great presentation by Casey Moratori that describes exactly why all terminals are complete shit and cannot ever perform. So yeah.
Not entirely sure that's the conclusion he gets to. But
he comes to the conclusion that what he's written outperforms anything that's out there, right?
Sure, using the same limitations he thinks the Windows team has, which is, I mean, it's interesting, and I think the really good thing about it is the way that he tackles that is by sitting down and saying, here's the raw throughput of the operating system, why is my terminal not matching that, or why is it off by like an order or two of magnitude? But yeah, and until you do your own terminal, it's kind of like, it's just interesting. It's like you still got to live with somebody else's. So I'm going to the bar, man, but yeah.
Sorry. What's the actual thing that does the font to window? Is it the terminal emulator, or is it the kernel?
Your terminal emulator is responsible for doing that. So it's either your terminal emulator or it's some library. But it's like any GUI application renders font. How does it render font?
Okay.
And it's the same as that.
Okay.
Yeah. Cool.
Awesome. Thank you very much.